In modeling the number of claims filed by an individual under an automobile policy, an actuary makes the assumption that for all integers n, Pn plus 1 equals 0.2 Pn, where Pn represents the probability that the policyholder files n claims. Under this assumption, calculate the probability that a policyholder files more than one claim. So we have this recursive formula. P1 is calculated by putting n equals 0 in this equation. So P1 will be 0.2 P0. P1 equals 0.2 P0. Similarly, P2 will be 0.2 P1 by putting n equals 1 in this equation. P2 equals 0.2 P1. But we already know that P1 is 0.2 P0. So substituting that value over here for the P1, we get P2 equals 0.04 P0. Similarly, P3 is 0.2 P0 equals 0.2 times the value of P2, which is this. And that gives us P3 equals 0.08 P0 and so on. Now, the sum of all possible probabilities is 1, means P0 plus P1 plus P2 plus P3 plus so on equals 1. And let's get all in terms of P0, because P1 is 0.2 P0, P2 is 0.04 P0, P3 is 0.08 P0. So we get this equation, and then we can factor out a P0 from this. We get 1 plus 0.2, 0.04, 0.008, and so on. Now this is a geometric series, and we know that the sum of a geometric series equals A over 1 minus R, where A is the first term, R is the common ratio. First term is 1, common ratio is 0.2 here, so it'll be 1 over 1 minus 0.2, and then we have this P0 outside, and then when we take this term on the right side, we get P0 equals 0.8. So P1 can also be calculated, that'd be 0.2 P0 from here. P1 is 0.2 P0, so 0.2 times 0.8, 0.16. Now, we need probability of more than one claim, which means we need probability n greater than 1. That is most easily done through the complement. And the complement of greater than 1 is 0 and 1. So probability n greater than 1 would be 1 minus P0 minus P1. And we have those values for P0 and P1. So we get 0.04, which is choice A.